Just a quick question while waiting. You can see full screen, can't you? Not just because I've got a go-to meeting window open on the front. So
It's a full screen. It's a clear screen.
Okay.
Okay, hi everyone. Can you hear me?
Yes, we can.
Intel Optane Persistent Memory webinar. I hope everyone is keeping safe and is healthy. Just a couple of house rules before we get started. Could everyone please mute themselves for this session? And if anyone has any questions, please drop them in the chat section below. Or if anyone's facing any technical difficulties, please email the marketing team. Or again, you can leave it in the chat section. So many of you are here today to understand what Intel Optane is, its success stories, and how it can help your business. But before we get started, I want to introduce our experts in this field. So we have Peter Kearney with us here today, who is the Senior Enterprise Solution Architect at Intel, and will be driving dialogue around what Intel Optane is and how it improves workloads. Peter has worked with Intel for 19 years and has experience in market verticals, including HPC, defense, research, telco, and many other large enterprise customers. And we also have with us Des Nguyen, lead systems engineer at DiGiCOR, who will be talking about how Intel Optane can help your business. And Des has worked with with DiGiCOR for over 10 years and has developed and designing customized solutions to drive innovation within customers. So we'll over to our first Peter. Thank you.
All right, thanks for the introduction. As mentioned, my name's Peter Kearney. I'm a solution architect at Intel. I primarily work with end user customers in the enterprise space and have been doing that for a number of years. So today we're here to talk about Optane technology. But the first thing I'll mention is if you look at the center. We do also have Optane technology in our client products, which are for accelerating elements of the I/O in desktop and notebook, but we'll be primarily focusing on the data center.
Sorry, Peter, we couldn't hear you.
Yeah, we've lost sound there.
Now I'm
Yeah, I think
so. Yeah, so we have processes and packaging, or did we get the 6 pillars of innovation? Yeah, so this is the 6 pillars of innovation of Intel. So looking at process and packaging, so we're a large manufacturing company, we manufacture our own silicon, but also looking at how we package that. So we package it in 2 dimensions, but also in 3 dimensions. So some of our upcoming data center GPU products even have up to 17 individual pieces of silicon on the package. So lots of technology and intellectual property around processor packaging. Here we've got XPU architectures. So everyone knows Intel does CPUs, but we also have some PUs, definitely our desktop and notebook already, but we'll also have some data center GPUs coming to market next year. We also our FPGA products for programmable systems, our visual processing units for accelerating edge AI and visual inferencing workloads, but also research into things like neuromorphic computing. So there's a lot of press around some of the activities we've got going in neuromorphic. Then we move up to memory and storage, which is primarily what we're focusing on today. So we have our 3D NAND products, but also a lot of work in the 3D cross technology, which is brand named Optane. And when we talk about storage memory products, not only is it about the actual product, how do you take use of it? So we've got a lot of work going on with our partners, but also DAOS. So this is our next generation system that has been architected from the ground up to make use of Optane persistent memory to accelerate that storage for the next generation high performance computers and the exascale systems that we'll be delivering next year. Then we look at gluing it all together. So interconnect technology, we've got a full portfolio of network cards, so LAN products, Ethernet, our OmniPath technology. We are a member of the Compute Express Link, which will be the next generation in Interconnect. This will coherent architectures across CPU, memory, and accelerator in systems, both in the hardware and software for security. And then we do a lot of work with software. So compilers, tools, performance libraries, debuggers, analyzers. And then we work very closely with our software ecosystem partners, the likes of Red Hat's, Microsoft's, VMware's, SAP, which we'll talk a little bit about as well, and all the way up through the solution stack. So that's why we think we're a little bit different to some of the organizations that we compete with. So in our data-centric portfolio, we have three mantras. They're move faster, store more, and everything. So in the move faster, as I mentioned, we've got a comprehensive portfolio of Ethernet products all the way from 1 gigabit up into the recently released 100 gigabit Ethernet. We've got our silicon photonics products for connecting them all together, our OmniPath products for high performance, low latency, high performance computing workloads. And we have a company called Barefoot, which is a lot of Ethernet switch silicon that you'll find integrated into a number of OEM products. In terms of store more, we've got our Optane persistent memory, which is the primary focus of this this presentation. We have our Optane solid-state drives and our 3D NAND solid-state drives. And then process everything. So we've got CPU architectures all the way from embedded and entry-level low-power Atom CPUs up through the highest performing Xeon Platinum CPUs. We've got our Stratix and Aria FPGA products, our Movidius visual processing units, and Xe is the brand that we have around our graphics processing units. All of these things are designed to work together in an optimized system. We then do it around what we call select solutions, reference architectures for how you build a what we call a BKM, or a best known method, or infrastructure to support different workloads. So today we're focusing on memory and storage. So store more. For many years, we've obviously had hard. We're now seeing customers and a lot of workloads are really moving to all flash technology. As we use the ability to manufacture flash, costs are coming down significantly, and we're seeing real adoption across the enterprise storage infrastructure for 3D NAND solutions. So we have our value products. The picture that you can see there is our ruler product. This is a new form coming to market. We'll be delivering products that have up to 32 terabytes on that small ruler. When we say a ruler, that's because the exact size and shape that it is. You can get 32 of those into one rack unit. So in that, you'll be able to have almost a petabyte of storage in one rack unit, a very high performance NVMe flash. We then go up into our sort of value and entry level NAND products, and into the write intensive NVMe products in our 4610 and 4510s. But then we have our Optane products. So Optane, or 3D Crosspoint, is a new technology that is completely unlike NAND technology. It's been designed specifically to address high endurance and low latency workloads. And so then we take that 3D Crosspoint technology and manufacture it into two different types of products to address this storage hierarchy. So we've got our Optane SSDs, which are really optimized for high performance and low latency storage workloads. So you would use these in the cache tier as an example for VSAN, or in log files, journal files, transaction files, anything that requires very low latency, high IOP workloads. And then as we get close to DRAM, we've got another gap where we're filling with 3D Crosspoint Optane, and this is the persistent memory product, which is what we're focusing on today. So the Optane product comes in a DIMM form factor. It sits on the memory bus right next to the DDR4 of the server. So as an example, in a 2-socket server, they typically have 24 DIMM slots. So you would potentially have up to 12 of these Optane persistent memory modules and 12 DDR modules as well. And so they're sitting right next to the CPU on that memory bus. So the Optane product operates in two different modes. We'll cover the memory mode first. So in memory mode, the Optane appears to the CPU or appears to the operating system as memory, and it operates as another memory tier in the cache hierarchy. And so these give the ability to have very high capacity memory footprints in 2-socket servers. And they're affordable. They're significantly less expensive than DDR4 technology. So they come in 128 gig 256 and 512 gig modules. So using a 128 gig module, you could potentially have up to 1.5 terabytes of persistent memory in a 2-socket, or even as high as 6 terabytes in a 2-socket configuration. In memory mode, the DDR acts as a cache to the persistent memory and doesn't require any change to operating systems or applications. It is completely transparent to those workloads. On the left-hand side, we have a mode called App Direct mode. So this is where the application is directly loading and storing bytes, not blocks, bytes, onto the persistent memory. In this mode, it is non-volatile, so the data persists through power cycles. So in App Direct mode, not only can you address it as individual bytes, but the operating system also supports a block mode driver on top of it, so it just appears as storage. So if you had 12 memory modules in there, that creates 2 namespaces, and you can then build a file system on those namespaces and just treat it as though it's a normal storage device. So App Direct mode is where we get very high speed, very low latency, high capacity storage. So having 12 of these sitting very close to the CPU, clearly you get very high performance I/O. And so now we'll talk about some of the use cases and the business value of the technology. So databases is one area that we really focused on as we were bringing the product to market. SAP and SAP HANA is one of our lead ISVs for persistent memory. And SAP HANA actually uses the persistent memory in App Direct mode. And HANA uses the persistent memory as a storage device to store the column indexes for the in-memory database, which significantly improves the performance of the database because of how much capacity you can have in the system. The other advantage for something like SAP is that it really changes the mission critical nature of SAP. Because it's persistent and it can store the column indexes persistent, if you do have a system failure, you can bring the machine up and the SAP HANA database is ready to go because those column indexes are stored persistently on PMem. Over on the right, we'll talk about virtualization. So when you're doing virtualization and loading up virtual machines onto your infrastructure, typically the first thing you run out of is memory as you put more and more machines. If you can support larger memory capacities with Optane persistent memory, you can then load more virtual machines onto those nodes very cost effectively. Similarly with Microsoft and Azure Stack. And then on the middle there, things like in-memory databases like Apache Spark, significant improvements in the performance of Optane. So Optane is still very new to the market. So a lot of ISVs and customers are still trying to understand the use cases and how it can help them in their business. So what we're doing is spending a lot of time building case studies and white papers, different architectures, solution briefs, and things to show how different organizations making use of persistent memory in different methods. So we'll be distributing these slides to you after the webinar. And each of these is a link to a white paper or a case study describing the business problem that the customer was seeing, and then the process that they went through using Optane persistent memory to understand the value and how it addressed those business problems. So I shouldn't have clicked the link. I should have hit the page down, but so plenty of case studies, and we're happy to help DiGiCOR and help the customers to understand the value, looking at proof of concepts or helping with understanding how it can accelerate the workloads in your business. So thanks for that. With that, I'll conclude and hand back to Roam or Des.
Awesome. Thanks for that, Peter. So given the nature and positioning of the Optane technology, I thought today we'd focus more on the virtualization side of things, especially given the prevalence of all the that you guys are running, and a good majority of the users out there are heavily using VMware and virtualized environments as such. So given that, one of the most popular products in our portfolio for that would be our high-density compute solutions that we've been deploying for quite a number of years. And as such, I'd like to give a run through of some of the Supermicro product family in that sense, especially with their multi-node architectures and being heavily deployed in VMware and Hyper-V and other virtualized infrastructures as such. So the Twin family has been around for quite a while, and it's been broken up into segments now with the positioning, the various features. I'll give you a rundown on some of the differences between the nodes and the functionality and how Optane can be adapted to these particular situations as well. So those of you who aren't aware, the twin solutions from Supermicro typically start in a 2-node or a 4-node scenario with various different storage options, whether it's 3.5-inch, 2.5-inch, NVMe, and they even scale up to the FatTwins as well, which are heavily used in quite a lot of our cloud providers and virtualized environments, and also HPC environments as well. So, with a discrete backplane that that's isolated from node, and also independent power supplies. The main difference between the product segment and the differentiation between them all are just specifications. So we generally go from the Twin Pro, Big Twin, or the FatTwin. And these typically start from 2 or 4 node configurations, and they scale up by memory slots. So the entry-level Twin and the Twin Pro are generally the most popular in the market. And given the nature of hyperconvergence and VSAN, the Big Twin, we're seeing a big jump in Big Twin demand as well. These have been quite a good niche, particularly paired with Intel NVMe drives on the front, and also the adaptation of the Optane memory DIMMs as well. And they come in various flavors of 2.5-inch and also 3.5-inch. But the big differentiator between them is the amount of DIMM slots available per node. So with the entry, we're getting 8 DIMM slots. With the Twin Pros 16, the Big Twins are 24, and the FatTwins are 16. Given the nature of Optane, we typically between 16 and 24 DIMMs is ideal, as we can run a balanced memory mode of just standard DDR4 and also the addition of Optane Twin. So to maximize performance, we still want each channel populated with standard DDR4, given the nature of the Xeon scalable second generation CPUs being 6-channel. So you'll see here that they come in a vast array of various different configurations, also flexible networking configurations as well. So we also have the whether it's 3.5-inch large capacity drives or 2.5-inch with adapter trays to convert into these bays, or a typical 2.5-inch U.2 form factor as well. This is a standard config that we are seeing a lot more of, and it's being readily deployed across virtualized environments, especially in hyper-converged environments with vSAN. And given the cost of NVMe drives over the past couple of years, it's becoming a lot more prevalent there as well. And especially with use cases like vSAN, where we don't need hardware array controllers, it's all managed via vSAN itself. This is the standard Twin Pro, which is probably still one of the most common solutions that are deployed across virtualized infrastructures. It's all fully VMware certified up to the latest version, and comes in a 1RU2 node, a 2RU4 node, and with 3.5-inch drives, and a 2RU4 node with 2.5-inch drives. And this would probably be one of the more economical solutions, as they would typically be deployed with Intel standard SATA SSDs like the S4510 or the S4610 as well. And this is just standard level, entry-level twin, which consists of 3.5-inch drives and also 8 DIMM slots in each node, and ideal for quite small virtualized environments that aren't really pushing the boundaries as yet. And as we scale larger, obviously the FatTwin is one of the solutions which is quite similar to the Twin Pro, but there are benefits in terms of cooling costs and as such associated with the density that's involved, and also there's more storage density available as well, as we do have the option of populating this with 3.5-inch drives as well. All these solutions come with quite a flexible array of networking options available in these particular systems, so they don't occupy PCIe slots, and come in the range of 1 gig, 10 gig fiber channel, and also InfiniBand as well. And these do not occupy any additional slots, so they do leave those systems available for the addition of other cards as well into these particular systems. One of the interesting points that we wanted to get across, especially in virtualized infrastructures, was the cost savings in these particular systems. So these are typically the Optane supported configurations, and what's recommended there as well. The users are also do consist of mainstream systems, which are all covered off, and essentially all the systems that we are currently pushing to market that are populated with the 2nd generation Xeon Scalable Gold processor and above are Optane memory compatible. And they all vary on the number of DIMM slots as well. But the next slide is quite interesting there, as we do, we can see some prevalence in terms of the costing and the focus there. So you'll see here, this was a slide that was compiled with Intel in conjunction with testing with Supermicro labs as well. So this is based off a standard config with Xeon Gold 6252 processors, and populated with 768 gigs of just standard DDR4 DRAM. And they're averaging probably around 152 virtual machines in this particular system. And given the virtualization requirements, it's the CPU utilization is slightly under. So you can see there the value that users are getting out of Optane memory. So on the right here, the configuration has been scaled down to 192 gigs of memory plus 1 terabyte worth of Optane memory DIMMs. As you can see, with the same processor and same configuration, the VM density has increased by roughly around 25%, and the cost per VM has been reduced simply due to the increased density in the compute, and also the cost savings that are associated with using Optane memory for memory. This would typically be a standard configuration that we would see across the board. It's probably one of the Supermicro hero configs that are heavily used in these sort of environments. So you can see here, it's the big twin that's fully populated with Intel NVMe drives, 12 gigs of 32 gig standard DDR4, and 2 terabytes worth of Optane DIMM in the system as well. And this was similarly based on the setup there. One thing to point out is with these particular VSAN certified systems, they will not, VSAN does not operate on app direct mode, and and only operates on memory mode. So given the flexible nature of the myriad of options available, this has been quite a driver in this particular hyperconverged market. And with the prevalence of Optane DIMMs, it is one of the key things key points to take across. A lot of users are also using some of our standard more popular systems like the X11 systems that consist of the X11 DPI motherboard, for example. We use this board in a lot of our standard system builds and a lot of the systems that are currently deployed in the field. And these, all the systems are compatible with Optane DIMM, and you typically see a lot of the support listed on the Supermicro website as well. As here, it's only compatible with the Xeon 2nd generation CPUs that are the gold SKUs and above. So one thing to take in mind is the silver SKUs do not have any Optane memory support, only the golds. Other than that, that pretty much sums up what I want to go through today. So I'll field it over to address any questions from the audience and all that sort of stuff. Thanks.
Thanks, Peter. Thanks, Des, for your presentation. We will share all of the slides with all of the participants, and there will be a recording of this video available on our website. I'm going to share the link with you. So I open the board. If there is any questions, please feel free to ask from Des and Peter. You can either message your question or chat section, or you can just unmute yourself and ask.
So it's Peter Kearney here. I'll start with one that the question we quite regularly get asked. Persistent memory requires DDR and persistent memory. The question we get asked a lot is, all right, well, how much? How much of which? So typically we say to a customer, when they're using persistent memory, if you've got just a mainstream workload where you're building a virtualization infrastructure for just running normal everyday virtual machines, then we would typically say an 8-to-1 ratio. So 8 gigabytes of persistent memory to 1 gigabyte of DDR. If you've got workloads that are a little more performance sensitive, or you're running some higher performance workloads like databases or analytics or transaction systems, we typically recommend moving up to a 4-to-1 ratio. So 4 gigabytes of persistent memory to 1 gigabyte of DDR. So they're kind of the ratios that we would recommend. That's in a fully populated system. As we saw Des presenting, some of those twin motherboards only support 4 persistent memories per system or per node, and so those ratios would still be similar to that.
So we've got one question here in regards to the population of Optane memory, and especially in single socket systems. So the question was, can I pair one DDR4 DIMM with an Optane DIMM? And the answer is yes. but it's not something that we would typically recommend or work with, primarily due to the nature of the architecture of the CPU, as you still want all 6 channels with standard DDR4 before pairing in memory, just to get the most out of the processor and the memory bandwidth.
Yeah, and just adding to that, maybe a little bit of the internal architecture. When you look at the motherboard, you'll see that there are typically 6 memory DIMMs. I don't know whether you want to bring up one of your slides on speaking, Des. You'll see there's 6 memory DIMMs that are generally colored blue, and then there'll be 4 DIMM slots that are colored black. So the Cascade Lake or the Xeon scalable CPU, yep, that's a good example, has 6 memory channels, and those memory channels are actually split up into 2 individual memory controllers. So typically, our recommendation would be to populate the full 6 memory channels, the DDR, and then you would need populate, in this case, those 2 black slots per CPU, and that's 1 per memory controller, and you would end up with 4 Optane persistent memory DIMMs in that configuration. That configuration is what we call a 2-1-1 configuration. So one of the channels has 2 DIMMs, a PMem and a DDR, and the other 2 channels just have 1 DDR. So there's a whole bunch of different population configurations that we do support. Can get a little confusing sometimes, but we're certainly happy to help you out to understand what works, what's supported, what's best practice.
I have a question for Peter, if possible.
Yep.
No disrespect here, but will the Optane memory work on an AMD system as well?
No, it doesn't. Full stop.
Okay. Thank you.
Just another note, because there was, and obviously VMware is one of our primary use cases. So VMware supports persistent memory at the ESX layer in, I think it's 6.7U3. Now, VMware can either operate in memory mode, where you just get the additional benefit of the additional memory, or the ESX layer can present the PMem in app direct mode up into, through the ESX into the guests. And in fact, if you're doing something like virtualizing SAP HANA, you can actually give access to the PMem directly to those SAP HANA guests. Well, there was a conversation about VMware support for vSAN. Currently, vSAN does not support PMem in the cache tier. Our current recommended configuration is an Optane SSD in the cache tier, and then 3D NAND technology in the capacity tier.
I've just pulled up a slide explaining the two scenarios that you're talking about, Peter.
Yeah.
So you'll see it in the first one, just in PMem. So Optane DIMMs is presented just straight to the hypervisor, just as pure memory. And the second scenario is in app direct mode. It's being used as persistent and fast.
And then you can send that fast storage through into one of the guests or into the guests. In VMware memory mode, VMware has this concept called hero configs. Now, VMware supports Optane PMem in a number of different hero configurations with a balanced performance profile. And so there's probably about half a dozen different hero configs that recommend for PMem to DDR memory ratios. And happy to help out, get you that information if anyone needs it.
Peter, this is Ali. I just want to know, we are using Optane memory as a boot disk or app disk here in this picture. So does Intel have RAID array arrangement with this memory setup, or with this disk?
No, so this is showing boot disks being separate. So it's showing the persistent memory as different parts of storage. So you cannot boot off the Optane PMem. That is not supported. You must have either a SATA, a USB, if you must, or an NVMe boot drive.
Whereas in app disk, you have a number of, like in a X11 motherboard example, you have 4 DIMM slots for Optane as an app disk. Is it right? And if we
yes.
have an app disk, then what is a range RAID array setup? Do you have a controller like VROC kind of thing for this type of memory, or for the?
So Des, do you want to pull up that slide again while we're talking? So
Yeah, sure.
the way the PMem is configured, the PMem, if you're using AppDirect, you would have, it would be presented as a minimum of 2 separate namespaces, and those namespaces are per socket. So in that configuration, if you boot it, it would be 2 block, and you configured the persistent memory in this way, you would see 2 block devices, which you could then use either MDM or LBM software RAID to build a RAID volume across those 4 devices. Does that make sense?
That's right, but how about the VMware setup? Well, definitely VMware demands a RAID controller card in their RAID array.
No, so VMware would just see it as 2 block devices, and you would present that up through the ESX as 2 block devices, or it actually comes through as 2 direct PMem modules, because you do have the ability to talk directly to it at byte level, because it doesn't have to operate as a block device. But any RAIDing, you would RAID across the 2 DIMMs on the socket. But that would be a striped RAID, not a mirrored RAID.
So it's more of the RAID 0 than RAID 1.
That would be RAID 0 rather than RAID 1, yes.
Right. As you said, Linux environment you can, but software RAID, I take it as in a Citrix Zen environment as well.
I haven't had a good look at Citrix Zen support at this stage, so I'd have to take that on notice. I'm not going to make any guesses about Citrix support. So feel free to contact me and we can dig that out. Or the other thing, if I do our official position, would be you need to ask Citrix about their support. But yeah, happy to do some digging and help get that answer.
Thank you.
Certainly Linux, VMware, Microsoft, they all support it, but Citrix and stuff, they're still a little bit, Probably a little bit behind in terms of some of the certifications and things like that, but it's when being used in memory mode, a vast majority of operating systems do have that support.
Yeah, and with regards to Citrix, VDI is really one of our hero use cases as well, just because of the number of VDI sessions you can support using the additional memory capacity.
Okay, if we don't have any other questions, I pass to Simran to do the closing bit.
Thank you, Rohan. Thank you very much, Peter and Des, for joining us, and that was very insightful, and there were a lot of important takeaways from your presentation. I would like to thank you all for coming, and we hope you enjoyed this session and found it useful. And please keep an eye out for the emails, as we would really appreciate it if you could please evaluate our webinar. And stay safe and well, and we hope to see you at our other events. Thank you.
Yep, thanks everyone.
Awesome, thanks.
Thanks everyone.